times 0.14.
Hi, Joyce.
Hi, Joyce. That was Peyton Manning saying hi.
Not Satan Manning, like George was saying earlier.
Who's Satan Manning?
I don't know.
That's heresy.
That's Frozen.
Okay. Joyce, I had them start in their notebooks and finish this example on Friday, but you're amazing. You probably already finished it. Anyway, and we talked to Gerardo about how, since there's a decimal, the AP would not require you to do this problem without a calculator.
They agree.
We were solving for who?
You're solving for dy dt, Jinx.
So you can say dy
I
dt
said it in British. In British.
is equal to 500 secant squared of
Pi over 4.
pi over 4
Times 0.14.
times 0.14
Radians.
radians per second. What did you guys get?
I can't remember.
140 over root 2.
In decimals.
We need decimals.
98.9949497.
Say,
That was a lot of 9s actually.
With the AP, just a quick heads up, remember you can either round to 3 decimal places or truncate at 3
I
decimal
got
places.
What's truncate?
0.995.
And you just cut it and don't round it.
I got 0.995.
Okay, so you rounded. What would the units be?
Feet per minute?
It'd be just radians, wouldn't it?
No.
No. No, yeah, no, 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 yes, no.
Well, I put per second, it's radians per minute.
Is it a minute?
Okay, so if it's radians per minute times,
What's 500?
I don't know.
Feet.
But
So if you want to think about it, it could be seen as feet times radians per minute. But is that the answer?
No.
No.
We don't need radians because that's
We don't need radians because we can look at our differential and say, what's y measured in feet, what's time measured in minutes? However, I do have a further or a better answer to that question
No.
on the next page, but for right now, what we did last year was say, hey, look at the differential, and as long as you solved it, right? You should end up with feet per minute. The only time it gets weird is, well,
When Satan comes in.
when you have to do some unit conversion, etc. However, where did the radian go?
Bum, bum.
A careful analysis. Once again, the book is helpful sometimes.
I
But
don't
the
know.
units example 2 gives you feet times radians per minute. Radian measure, though, is actually dimensionless, hence why we use it in calculus. Adaptable to whatever unit is applied to the unit circle, because the unit circle can be in feet or inches or miles or anything in between.
Ooh.
The linear units are measured in feet, so feet times radian is simply feet. So it's not that we're ignoring the radians, that the radian is dimensionless. And all we did is plug it into our calculator, talk about how technically it's feet times radian per minute. So why on earth is it just feet per minute? And then we looked at the snazzy thing from the book that said,
It's one.
radian measure, dimensionless, adaptable to whatever unit you're dealing with, so therefore feet times radians is the same thing as feet.
Because radian is 1 and feet is 2. And 1 times 2 is feet.
You're a little loopy. What's going on with you?
I took some drugs.
Really?
It's called JC.
JC, the security guard?
No,
Just talking?
JC, the Jesus Christ. Woo! I'm sorry.
Okay.
Now I'm curious. Good Debo? Or are you just making up stuff?
Oh, I'm making up stuff.
Over root 2.
Do you sleep this weekend?
No. What is sleep?
Good question.
Look at George, wide awake, happy. It's a good Monday. Okay. New problem, ready, set, go. You've seriously been in a great mood for the last week.
Have I?
Mm.
I don't remember.
Until we went walking.
What are you trying to say?
Actually, I thought he
My life
found it
depends
wrong.
on
That's only
football.
3 days.
That's
No, I'm saying there's a broader, I just don't know what it is.
Like I
A
said,
pebble.
like I said, he probably found it wrong.
A pebble is
I'm
dropped.
defined by a woman? In the
Could be
in
a
the
fountain
from?
though.
Misty, what causing ripples in the from of?
in
I'm confused.
form.
just
Form.
concentric circles. There you go.
Oh, I thought that was.
You know the sad part?
Hmm.
I didn't type it. The other book did. The book from last year struggled, right?
Destroy their families.
from saying from instead of form?
Yeah,
Him did it right.
never mind, I just screwed up, sorry.
Did it combobulated you? Confused you?
It confused,
Yeah, because I thought it was legit from, so I thought that I was missing something.
A pebble is dropped in a compound, causing ripples in the form of concentric circles. The radius of the outer ripple is increasing at a rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area of the disturbed water changing?
Boom.
I dropped my check.
So we need area. Where is
George, how are you able to say that? You said, so we need area.
Because it said the total area. What rate is the total area?
That's our
Our
quantity
formula.
that we're trying to seek, right?
Primary function.
So the primary equation that we're dealing with, the primary relationship we need to work with, area equals pi r squared. But thinking about our given and our find, or what we know and what we seek in the book's terminology, what are we given?
DRDT equals 1 foot per second.
So it says the rate at which the radius is changing.
R equals 4.
It's growing, so
You
it's
guys
a
are going too
positive.
fast. Steve, could you go back because I was still writing the problem, so when you guys were explaining as to the
Okay,
why.
remember I have suggested that you don't write the problem. Okay? So, coming back. George was like, hey, we need area. And the whole reason I asked him was technically so that all of us could figure out what's going on. Okay? So when I said, why do we need area, George, why did you say that? George, what did you say? One more time.
Because they're asking for the rate of area, so that's our primary function.
Rate of area, so our primary quantity. And our relationship that we need to think about our quantities is going to be the area formula of a circle. Talking about radii, if you look right here. Talking about area, if you look right here. So then the formula that relates area and radius in a circle would be a equals pi r squared. Then I said, hey, we need to think about our givens and our find. This is what we're going to be using, but what do we know and what do we seek in the book's terminology? The only number now that's dangerous to jump somewhere in a problem, but we read the whole thing first. The only number, the only quantity that I see is 1 foot per second. What does that go to? Just read before. Rate. Whose rate? Increasing. Positive rate. Whose rate? Radius. So dr dt, what? Because it's a radius. Dr dt is equal to 1 foot per second, positive because it's increasing. Now go find the question mark and say, oh, when the radius is 4 feet, that's a such that. That's a clue that we know. What is the rate of the area? Now Gerardo, how would we say rate of area?
dA dt.
Perfect. Use the quantity that you have, which is A for area. The ADT is what we're trying to find. So then everybody, if I need the relationship of the rates, I take the relationship of the quantities and
Derive them.
derive
Derive them up the wall.
Derivative of A is dA dt, because I'm taking the derivative with respect to time.
2 pi r dr.
Bring down the 2, the pi is a constant, the r stays times, and then we have our extra dr dt. And the name of the game is
Plug them in, plug them in.
plug and simplify.
Turn them, turn them, turn them, turn them.
Turnip. Those aren't yummy.
Have you ever had pickled turnips?
Are they good?
I'm not a huge fan of pickled stuff.
So no.
Sorry.
I'll get you.
I've had some pickled.
You'll like them. I think.
I've
Wait,
only
what's a pickled
gagged on
radish?
food once.
Really? Impressive.
And it was something wrapped in pickled grape leaves. I just couldn't do it.
Pickled grape leaves.
You know, like the grapefruit?
Is it grape leaves? I don't think they're pickled though.
Might be Armenian.
Yeah, the doma, whatever. The Armenians call it doma, but we call it grape. I mean,
It's like little rolls, like an egg roll kind of, but with
they're not pickled.
isn't there vinegar or something? Like they're soaked in something.
It's not that they're soaked. It's salty a little, but I
What
don't.
is it?
It might be vinegar.
I don't think it's
Vinegar
soaked in
pickles
anything.
Okay.
My aunt's making good. I'll bring you some good.
But it's that, like, I gagged on it in Israel, because they always had like
Oh,
Mediterranean-ish
it's probably
stuff.
them.
And then I had a kid brought them for lunch and was like, here, you want one? No. I choked
Did
it
you
down.
eat
It
them
was
when we went
rough.
out with
It was
Nam?
really loud. I was like,
You went
You
to,
didn't eat them when we went out with Nav for Layla's graduation thing?
I think I skipped them on purpose.
Forest. Those are good ones. Those are our real ones, but I'll get you better ones.
Misty, you went to
I don't
Israel?
think they were there. Were they?
Yeah, those are good ones.
Maybe I had it, I didn't notice it. I don't know, it was rough. I spent a semester in it though.
Oh, so that's what you meant by semester abroad.
Mhm.
8 pipe.
You guys solved it, right?
Yeah, I got 8 packs.
So it's D-A-U-T. What are my units?
Oh, wait,
Square
feet.
Oh, the feet squared? Yeah.
I forgot.
Did I catch you?
So that'd be-
Because I put feet as feet squared
Feetsies.
per second, right?
Mm.
And those of you guys that caught that, how do you know?
Because you got feet times feet.
If you think about it, yeah, you could say that that has feet and that has feet per second, so then feet squared per second, or areas measured in squared
Oh.
units always times measured seconds.
Now I get it. At first I didn't understand feet squared per second, but now I get
Does
it.
that make sense?
Yeah. Oh, what?
Don't write. Check it out. If you're talking about velocity of a car, we already know this one, right? Velocity is dx dt, is
Yeah.
the derivative of position with respect to time. If water is being pumped into a swimming pool, why are the cubic, or why are the meters cubic?
Volume.
Because volume.
Volume is changing, right? If a gear is revolving around at a rate of 25 revolutions per minute, and they say 1 revolution is 2 pi radian, which we should know anyway, what are the units of the rate of the gear?
Radians.
Radians, exactly, so angle,
Oh,
d theta dt.
Oh, I didn't even know you were asking.
I know, I was gonna tell. What variable, what quantity would you be thinking of? So when we have things revolving, and when it's not talking about, sometimes there's a silly problem out there with like a tack on the outside of a bicycle wheel, or like a fly that's gotten squished on a bicycle wheel, or someone on a Ferris wheel. If you're talking about the actual measurement, like the actual distance that they're changing, there might be some revolving problem where it's like feet per second, or per minute, or per whatever. But if it's talking about the actual revolutions themselves, it's talking about angles, just something to keep in mind.
You know how you made the word asymptote? Can we
Mhm.
say revolutionizing instead of revolving?
I don't really know if I say it that much. Revolutionizing.
Yeah. Be amazing.
Yeah, population of bacteria.
It's increasing at a rate of 2,000 per hour.
That was what?
That's
Oh,
one of those, what do you say, it's not an angle, it's not a volume, it's not an area, it's not geometric, so we just name it x and say, okay, fine, x is the number of people, dxdt.
Sorry.
Sometimes you have to make up variables, but sometimes there are ones that easily go with.
Yeah, amazing.
Does that make sense?
Yeah. Yeah, because he's like, oh, this is my white person name, so I'm just gonna call myself X, because I don't know my real name. That was his whole thing.
So his name is all names, because x could be any name?
Yeah.
I did not know that was the reason. Interesting. You guys ready for some interesting ones?
No, so I want to leave now. I don't want to do physics.
Okay, how about we do calculus
Calm
then?
down, it's calculus. Which relates to physics, quite a lot. Okay.
Physics needs us. Without us, there's no physics.
True.
He has a
Yes,
point.
Steve. If these are on whatever exam, will we have the formulas given to us?
Yes.
Like the K equals 1
Yes.
half? Okay.
Yes.
Even last year they gave us like.
The only ones that they
the
get,
volume of a
right, the only ones that they kind of assume is maybe, wait, what did they give you last
They
year?
gave us volume. I'm pretty sure volume of a sphere. They gave us like a lot of things that I thought that I tried to memorize
Right.
because like.
But I can't tell you at the beginning of the year, like, just ignore them all, because then there's just means something like area of a square that someone somewhere doesn't know, and it's like.
Area of a square.
Cool. Some people, I'm not kidding. Okay, come back. The kinetic energy, K in joules, of a moving object is given by the equation K equals 1/2 mv squared, where m is the mass, v is the velocity. The mass of a rocket decreases at a constant rate of 25.
Wow.
25 kilograms per second. Interesting, due to the burning of its fuel.
Ooh.
Oh, I get it.
There you go. So it's not the actual rocket that's deteriorating, it's weight.
But that would still make sense actually, because if it's entering the orbit, it's like burning up.
Mhm. When the mass of the rocket is 6,000 kilograms, the velocity is 12 meters per second and increasing at the rate of 2 meters per second per second. What? What's per second per second?
Well, acceleration.
Second square?
Mm-hmm.
It's not per second square, is it?
Yeah.
Oh yeah, because Yes, second over one.
And you can tell he was like typing in a program, the guy I got it from, he was typing in a program, and he like imported an equation for that one, but then he just said per second.
Lazy bum.
I don't know. At this instant, how fast is the kinetic energy? Changing.
You give us a lot of
Can't you just
info.
do dk dt?
Okay, so how fast were we trying? We have our relationship, right?
Yeah.
K equals 1/2 mv squared.
Find DK.
We have plenty of givens. We definitely have a find. Sometimes it's easier to identify the find first and then go back and see what else we're given. So when they say, how fast is the kinetic energy changing? Kinetic energy is who, Gerardo? You already said it.
Okay.
So I can say dk dt. Now they said at this instant. Front row, what's going on at this instant?
Mass equals 6,000,
Mass is
velocity equals
6,000.
12,
But the velocity, oh yeah, velocity.
and then
Now, technically, sometimes the givens show up in the such that. Can you guys help me out? Why do I, just think into my teaching brain for a second, why am I not putting 6,000 in the given and instead I'm putting it in the such that?
Because it's an instant.
It's at an instant, it's not a constant the entire time. Now, here's the strange thing. Why am I also going to put down d v dt?
because it's
Because-
increasing at that rate. It's a
At that rate, at
that
this moment, right?
Can we just write b?
So could,
no, because
No.
v is 12.
so the velocity is increasing.
Velocity is 12 and increasing at a rate.
Oh, sorry.
Do you see it?
I
So technically, if I was doing it in the order of the problem, I just went a little out of order. V is equal to 12. What are we talking about, meters?
Yeah.
And then dv dt is 2 meters per second squared. So, kind of awkward because I don't really have a given, but do I really need a given?
Wait, you have one given though,
What's my one given?
the 25 kilograms per second.
Oh, nice, thank you. That's constant.
Just
I forgot I had 3 quantities. Alright, cool beans. So now what?
I'd say drive k.
oh wait,
Uh-oh.
then we have dmdt. So we gotta find.
We have the MDT.
Oh yeah, then we're fine.
So we're okay. But we just need to think about what? When we take this derivative,
Maybe just.
how are we gonna find it?
We gotta do product to unchain one. Swag and yoga.
Ooh, ew.
Wait, why'd you box the 1/2? Constant multiple.
Yeah, but this way it actually gets in there. If you want to, you can have the 1/2 be out in front and then do the MV. What are you guys doing?
I'm just putting 1/2 parentheses.
Okay.
Which is a lot easier.
There you go.
Why are these problems so easy and the one that homework?
And homework are so much harder.
Like this one, they literally given everything.
Yeah.
I haven't had to search yet.
Thanks for showing me.
Literally given everything. 4 times 12 is 48
I was switching
times
on my
6,000.
This is a nasty mistake.
That's not that bad.
Well, I guess not, because they give us some stuff. The ITK they give us.
Everything.
You guys plug it in, check in?
Mhm.
Yeah, but I need to
Give us, Mass is 6,000.
Is there something we haven't considered?
It's decreasing.
negative. Oh, did I not?
Whoo! Did anybody else catch it?
I put it on my paper.
Oh, nice.
I wasn't really paying attention.
Oh, this is gonna be so gnarly once we finally do everything.
Or you can plug it into the calculator.
I guess you can factor out a meters per second.
Well, they give you the.
They give you all everything.
Oh, I forgot. Can I make it work?
Joules per second.
Yeah, but I think that's kilograms meters per second squared.
Mm-hmm. Not. Wait. Say it one more time?
kilograms
Oh.
meters squared per second cubed?
Wait, no.
I think it's, cause I have kilograms times meters per second times meters per second squared, so I have kilograms meters squared per second cubed.
No, it'd be a second squared, wouldn't it? Oh, squared and then squared,
Mm-hmm.
or squared times an additional one.
Mm-hmm.
Huh.
So,
That's not what I remembered it to be, maybe it is. dk dt is equal to, what'd you guys get? As a decimal, three places, please?
No, that's
Shouldn't be any decimals, right?
142,200.
wait, why'd you put negative 25?
Because it said the mass is, yeah, decreasing. And then we can just say joules and be done with it. Perfect.
joules per second.
Nice. Good, connect. Energy is measured in joules,
And that's
time is measured in seconds, and then we're good to go.
On one of these, will they tell you the units also? Like they said it on this one?
They'll give you, like, for kinetic energy, they'll give you joules.
Oh, okay, yes, yes, yes.
Or they could give you newtons, like, with a different type of energy.
Is the answer upside
Oh,
down?
hey, look, force. 142,200, nice.
Yay, we're gangsters.
Oh, yeah, they answered right there? Sick nasty.
Okay, number next one.
Big mass.
I put the answers there so we could double check. Number 2,
Newtons.
the force in newtons.
Newtons?
Newton.
I'm sorry, I like
For the moving object is given by F equals ma, where m is mass and a is acceleration. You should have known that. A rocket sled, ooh, is propelled along a track with an acceleration given by, there it is,
It's a pretty fast acceleration.
for t greater than or equal to 0, which makes sense because, well, when t is equal to 6 seconds, its mass is 10 kilograms and is decreasing at a rate of 0.2 kilograms per second due to the burning of its fuel. At this instant, how fast is the force changing? Why are these, as you guys would say, easy?
Because the
Even though they are very applicable when dealing with very physicsy type circumstances.
They're giving us all the givens and finds.
Yeah, they're giving us all the relationships, all the quantities, and we don't have to worry about the geometry of what's going on like some other ones in homework,
There's
right?
no birds.
There's no birds that we have to worry about.
literally in homework, they're all birds, no givens.
Yeah.
We're like one given.
But hold on,
to find
this is a
it.
little bit different though, yeah?
Yeah, they give us two.
2 equations, what do we do with acceleration? Well, hold on, what's going on?
We can plug in, I guess.
When
you could
t
say.
is equal to 6 seconds, this is our such that, right?
Because we're gonna need
When
acceleration.
t is equal to 6, its mass is equal to 10 kilograms. Anything else? And it's decreasing
T is negative 0.2.
for dmdt, yeah. And it's decreasing at a rate of,
Negative 0.2.
So you're right, negative 0.2?
good. Kilograms per second.
Because then we need acceleration.
We're given an acceleration, yeah?
I think you can plug acceleration into MA, so you put F equals M times 5t squared plus t.
So why can't we just plug in T into A of T and get acceleration?
But that would be a constant, and remember we have to think about it as varying. Because at different times, the acceleration is gonna be different, so we can't just plug in a constant, because it's not a constant acceleration the whole time.
But at 6 seconds is not what they want us to do.
True, so after we find the derivative,
Right,
which is what we're trying to find, right? df dt, is that true?
second and first. So 8 times the MDT plus times
With all of our such that's, we can go ahead and start plugging and shoving, like,
You could say
acceleration at 6 seconds, oh, we'll get that in a second, dm dt is equal to negative 0.2 kilograms per second plus our mass is 10 kilograms. Uh-oh, how do we do d dt?
A prime of 6.
what's a jerk? You never really explained that.
Triple derivative of position, second derivative of velocity, first derivative of acceleration. It's how the acceleration is changing.
Okay.
And then we just derive and plug in.
So then A of 6, anybody plugged and chugged yet?
20.
260? A prime is equal to 10t plus 6, 10t plus 6 times, or plugging in, sorry, would be 6, would be 66, yeah? So our final answer for df dt, which should be measured in newtons per second, ends up equaling 660 minus
608, that's all?
1/5 of 260. You guys agree? Uh-oh.
My bad. Maybe
1/5, that'd be 4,
I,
43.2.
I had 655.68. So it's 216 times negative 0.2.
260 times negative 0.2 is 52, negative 52, right? Oh, 216.
216, yeah.
So
Divided by 5 to be 4 and 3, 43.2.
no, it's negative 4.
So then 660 minus 43.2 would be 6.
Oh, that's what I did wrong.
16.
I'm sorry. I did 216 times negative 0.02. I do that a lot for some reason.
616.
Does that look good?
616.
Newtons.
Newtons. Hey, look, we got it. Okay. So let's go have fun with another one.
Are you not into tens?
Woo! Let's go back to geometry just a little bit.
We should have to know that such that will be when they give us like at this point is this. It'll be like.
Because it's not constant for the whole situation, it's only to be used at the very end once you have the relationships for one instant in that whole model. The radius of the sphere is increasing at a uniform rate of 0.3 inches per second.
So GRBT is equal to.
At the instant when the surface area becomes 100 pi square inches,
So
what is the rate of increase in the volume? Uh-oh,
They want us to find.
struggle.
we gotta solve in terms. We gotta solve for S. No, solve for R in terms of that. No, I don't know what to say.
We're given dRdt equals 0.3, right? And that's a constant? At the uniform, yeah. Oops, meant to be red. And increasing, so it's gonna be a positive 0.3 inches per minute, or per second. At the instant such that surface area is 100 pi. What is the rate of increase of the volume dV dt? Can't we still say that dV dt? Uh-oh, how'd that happen? Is equal to, bring down the 3, cancels out, 4 pi r squared dr dt? That's still okay, right?
Well, how did you get there that fast? Oh, you just drive velocity. Volume.
Yeah. So long story short, I have my 0.3, but what is my quantity that I'm missing? R, but I have S. Oh, so all I need to do is use whatever S is and solve for R? Why, yes, indeed, good job. So S is kind of a burr in the sense of like, oh, hey, I'll give you this, and you have to figure out who R is yourself. And you're like, oh, okay, great.
Equals 5.
Yep, 25 equals R squared, so R equals plus or minus 5. We're dealing with real objects. So therefore, it's just going to be positive 5.
What's 100 pi times 0.3? Or 100 times
0. So we
R
end up
squared.
with
Why is R? Wait, where'd you get 100 pi from? Don't tell me 4 pi r squared is like.
they told us surface area was 100 pi, so we could set S equals 100 pi and solve for R to be able to figure out who R is in this situation. $30 pi, right? And volume, it would technically be inches cubed, because it's volume per second.
3.
Final answer is So one way it might get tricky is if they give you one measurement, but you aren't straight plugging that measurement in, instead you're using it to get another measurement. That's kind of cool. Some of you guys are like, the funnel problem.
Yay!
Oh my gosh.
You know,
Go back.
I think Joyce is having a relapse because that looks like the black hole she drew for her physics project.
That's funny.
Or
Might have been on
she took
purpose.
the
Anyway.
AP exam last year.
Oh yes.
So, where do related rates come in on this problem?
They don't. I'm just kidding.
Or do they?
Okay, so they give us radius. No, they give us height.
Look at the question. A. Find the average value of the radius in the funnel. Average
Is that
value.
related rates?
That's a rate, not
No.
related.
No. That was just a
Find
plug
the
and chug
volume
into
of the
your,
funnel.
anyway.
That's
B.
plug in. The funnel contains.
Find the
C.
volume of the funnel, circular cross sections. C.
Circular cross section.
C.
We'll come back to it when we get there.
It's at C.
C, I see rates, and I see them asking for a rate, and I see them giving me stuff, and then asking me stuff. I think this is where related rates come in, right? So we're just looking at C, A, and B. We're plugging in the formula.
Plug and chug.
The funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is H equals 3, oh, that's a such that. Right?
Relief.
So we have our formula up above, our R equals formula. Given, well, our givens include our height. The radius of the surface is decreasing, so we have our such that. Height equals 3 inches.
Negative.
We have our dr dt exactly, George, equaling a negative 1/5 inch per second.
Rate of change of the height.
And they're asking us to find exactly, so therefore?
The change in the height of the liquid. So dH dt.
Mm-hmm.
I can get that part.
So we're trying to find dH dt. Given, well, all that stuff. And there's not really a constant thing going on, right?
No.
But we don't really need a constant thing, because if we need dH dt, there's the h, and we have dr dt, take a derivative. If you want, you could go ahead and rewrite it first and make it 3/20 plus 1/20 h squared, and then you could go ahead and take a derivative, so dr dt is equal to 1/10 h dH dt, which that would end up being dH dt is equal to multiply up the 10, divide the h times dr dt, which at this instant would equal 10/3 times negative 1/5, which would be negative 2/3. And what is our height being measured in? Inches. What is our time being measured in? Whew.
See, I don't think that's the answer. When I did it on the test.
Why'd you get 10/3?
You got the process of it?
No, like, I think I didn't do it right.
You might have been spazzing out about B and B. Probably B. Because average value, just do 1/b minus a.
Yeah. I think I just couldn't figure out the volume.
How did you
Volume is literally just pi r squared, plug in the R formula.
Like, where's the H? Oh, H is 10. I don't know. So much easier now
For
than
B?
using it.
No.
I just know everyone was so.
No, seriously, it was all over Twitter, it was all over everything. Everyone talked about the funnel problem.
I like this one.
I know, it's not
What
that
was
bad.
the one with the crazy graph?
That wasn't a function.
Yeah, that's why you had to derive it implicitly and then plug in, you had to take a double derivative and then plug in dy dt or dy dx exactly.
And that's when I'm
That was-
playing
yeah.
AB that you complained about last year.
No, that's what you told us last year. That's why I was like, I'm not forgetting. I was like, because like, you literally yelled at us every day for it.
What?
Because like kids would like
Complain
you
about
had to take a
implicit.
double derivative and then implicit
You
differentiation,
derived by x prime t?
and then then you put dy
do a
dx
second
back
derivative?
into the second derivative,
Yeah.
and then it's like,
The
but
year
everybody
bef-
forgets to do that.
2 years ago, all the kids were complaining about the second derivative of implicit, like, you didn't teach me, you didn't know what to do, blah, blah, blah,
You should
blah, blah.
plug in.
I said plug in. And then 3 years ago it was limits, and last year it was the funnel, and I don't even know what else. Was there like a topic last year?
Mm-mm.
Not really.
There
just
was
the
one,
funnel.
there was a falling ladder, it was the last FSU.
This.
The last one was with the, like, you do epigrams and like epigrams and things.
And it was a different one, but there was one about a ladder falling.
I remember that one.
I think it was on the Steve's practice.
If they don't give you a
What was the
given,
actual one, was it not, I thought it was on the actual one.
Because it was the last problem on the Steve's practice exam for multiple choice, that's what I remember.
So we could say related rates, because if we have a falling ladder and this one,
Yeah. Which means this year it won't have that. Yes.
theoretically. So there's only one part.
At least for,
BC though, I literally went back 10 years, and I couldn't find a related rates part of a FRQ.
really.
I mean, they're gonna do it this year.
Maybe, I don't know.
Misty.
Or
That
at least
meals
they
is
think
even-
it's an easy problem, so.
Yeah, it could. Gerardo, go ahead.
If they don't give you like a formula that will relate the two rates,
It has to be a geometric something or others, or
yeah.
they give you a formula that relates two things and gives you an extra clue to help you find what you need to know. Like with the surface area and the R. With that, we get to the end, but you guys were like, homework was scary. So,
Work on some of it? Well, we only got like,
you guys can open up your spirals. We still have a little while, don't we?
do we have till 39?
39, yeah. I'm gonna open up the ebook. I want you guys to show me the ones you don't like.
Did the ebook
16.
wouldn't open for me for
Are
some reason.
you serious?
You
I
might
know
need
it's
to
because it's on
update.
my phone.
But you were able to log in, okay?
Yeah.
I couldn't go to mine because I had to update my Safari,
Oh,
and my dad wasn't there, so it really wasn't happening.
couldn't you do like Chrome or Firefox or no?
I have no, because
You only have Safari?
I only have Safari,
Oh.
and then I can only update anything without asking, only with my dad's permission. So it's just a whole.
Well,
Misty, number
it's okay. We
16.
respect him for that.
No, number 19, not number 16.
16 too would be nice.
I could do 19 on the board if we, or I mean 16, not 19.
I can do 19.
Give me 19.
16, 19, 20,
20.
25,
I didn't get that far.
29,
I got up to
32.
16. I got up to 19.
Okay, who has 16?
42.
I got 16.
Go for it.
Yeah.
You have the little boat of markers. Amanda, you wanted the other one, right?
Yes.
Take it. And then, Amanda, where is it? Where are we past that? 16, 19, where is the next one? 21?
20, 25,
25. Okay.
32,
I'll just take this one.
29, 42.
Good.
I like 42 because it's common.
Okay.
Yeah, that was funny.
I know, right? I picked it on purpose.
She was like
That was just
in the
for
middle
you,
of what's it called? Personal finance. She's
I
like,
turn around,
George, look at 42.
Number 42 for me. I can attempt to do it. I didn't really have time to look at it.
Okay. So related rates, we'll start at number 20. We should go here though. Then we should go back to 20.
Because I didn't know what the formula is.
I guess I could just
That's
start
my
the homework, right?
Yeah, I suppose. Or you could follow along with what people are doing and see if it makes sense.
Yeah.
Filling a trough.
I just didn't know how to do the formula for it. It's a prism.
Yeah, it's like a.
Oh, okay. I think I got this one.
It's a right
Isosceles.
It's an
One-
isosceles
isosceles
prism, right?
pyramid, yeah.
Times
Pyramid or
one
whatever. It's like you're Satan.
volume of-
I don't love you, and neither does Jesus.
That's what I
It's
wrote, but
prof.
I'm not sure if that's right or not.
Miss D, for that one, would it be 1/2 base times height times length?
Yeah.
Oh, can I?
But did we do the base? Oh yeah.
No, I just
Hmm?
didn't, wasn't sure on the formula, so I didn't do it yet.
Did they take into the base, like
I
base
know how
height
to
base,
do
so
it. I
base
just
times
didn't-
height, and
I
then.
wanted to
Yeah,
try
they
to
gave you the
write
across and then the down.
But I'm talking about for the formula, because you would have to have the base, which is so base times height,
I don't have more classes. This
and then you need
Because
height
this
of a
could be-
triangle.
is forever.
Well, this could be base. Base and then times length would be like, if it was up on the end, it'd be area of the base times the height. Like if you were to stand it up.
Like this, and then
Uh-huh. See?
This
So then
one?
the triangle would be your base and then the length would be your height.
I never finished that.
what about this
homework.
height? Can we need this height?
Oh, which one?
The height of the triangle?
Oh no, Miss
Yeah,
D.
they gave you that one too.
I know, but like, what's for the formula though?
Oh, just think triangle, 1/2 base height,
Yeah.
and then times length would give you the third dimension.
Not in order to go.
Okay.
Does that make sense?
Okay.
Does that work, Amanda, on 20?
Yeah, now that that's all I really need to know is to make sure I have the right one. So I think I'm good on that one.
So then 25?
5. This one is just weird. It's talking about a parabola.
A
And then
parabola.
you
Ebola?
have to figure out the angle of inclination.
Go Santa.
Why did you jump?
Scared me
That was so
so.
funny. That was so funny.
My heart.
The particle moves along the parabola. I always sketch these. I don't know, some people probably don't, but.
I sketched it and then didn't know where to go from there.
Are you kidding me right now? Oh. It's not plugged in. Plug it in, plug it in.
Do your representative point, yeah?
Oh my god.
Yeah.
X coordinates, so that would be.
This is the worst sharpener ever.
So we have the X degree. That's the angle of inclination, theta dg, of the line joining the particle to the origin.
So we have 8 equals.
Angle of inclination. I'm assuming, because angle of inclination, you're inclined, is that be coming up from the x-axis? That's why I labeled that one.
So it's a triangle. It just happens to be the point that we're along.
That's what's restricting it, and that's what you're gonna be able to use in the sense of y equals x squared. I bet that's gonna be your.
Okay. That makes sense. I just was really confused on what it was asked, like where
Yeah,
to draw.
like how to put it all together.
Yeah.
When x equals to. So I would just use tangent, right? Because that would relate y with x.
Is that us?
Right?
I just got up here.
Misty, can I come up to you at lunch and ask you about, I actually didn't finish the homework from last week.
So do you have questions on it, or do you need time to work on it?
I need A, to work on it, and B, I'm stuck on 44.
Okay, from
Like Thursday.
5, 6, right?
It's
Or
5.
5.
By 5, yeah.
Five.
So I can't start this homework until I finish that homework.
And then Misty, I just have one question on number 20. It's asking for how fast
We
the
could do-
water is rising. So is that, we already
DHT.
DHD, there we go.
Does that make sense?
Yeah.
Rising?
Yeah, I was gonna say, it can't be the volume.
They would have been more specific if it was volume.
Misty, you gonna be in here next period?
No,
Yes.
they demanded this.
But another class is in here. Oh, maybe it's not, because Coach Trapp is gone. I think they're mostly high schoolers.
Oh, true.
What? I have a quiet room, 5th period?
Because I might come in.
I should be pausing.